seems like there's some confusion on Chapter 2, so I'll do two videos, one for Section 2.1 and one for Section 2.2. Now, I'm going to give you some advice. The students that have done the best are the ones that have taken some time to read the textbook. Now, in the section, there are examples, and they give you solutions, and they're really well done. So I don't do all of the examples during class time. Those are a good resource to try to get a handle on this stuff if you're struggling. Now, let's look at some of the major topics in Section 2.1. This cumulative relative frequency graph. Now remember, this has to do with the percentages. So it's kind of like a percentile graph. So in other words, if we wanted to know the 50th percentile for, these are telephone calls, in other words, how long were the calls, let's see, how should I say this? The 50th percentile. You know what, let's just do it. Right here, at 50%, we draw a line across, and then maybe down. We're just kind of estimating. So we're right at about like 18 minutes. So what we would say is that 50% of the calls were less than 18 minutes. It's like a percentile graph. So here's another thing. Don't forget that quartile 1 is really the 25th percentile. So if they ask for quartile 1, don't get confused. That's the 25th percentile. So we'll call that Q1. So we might say that, what does that look like? Maybe 13 minutes. So 25% of all the calls made were less than 13 minutes. How about Q3? Well, that's at the 75th percentile. So that might be up here. And down, and we say, somewhere around 34 minutes. So for Q3, which is at the 75th percentile, what does that mean? Well, 75% of all the phone calls were less than, say, 34 minutes. Okay, I hope that helps. Let's go to the next thing. Okay, let's not lose sight of what is mean and what is standard deviation. So very quickly, here we go. Let's just say that you have a national test that all high school students are going to do, like a physical fitness test, say. Okay, so some kids are going to be super, super fit, but not a lot of them. That is like an elite athlete. And then not a lot of people are going to be down here, which is where they can't do very much at all. Most of the people are going to be able to do most of the test, right? They do a pretty good job, and this is the average right here. So right there, that's the average. So what the standard deviation is how close are you to the average? So a small standard deviation means, oh, you're pretty close to what a lot of people got. Okay? A large standard deviation means you're out here, and that brings you into where not so many people got this score. So you're outside. So like if you had 2 standard deviations above the average, you would be out here, okay, super fit student, versus down here where maybe you don't do very much physical activity. That would be a large negative standard deviation. Remember, standard deviation is how far do we deviate from the average. Okay, now let's go on from there. Okay, I think we have a pretty good idea of what the z-score formula does. Take the number we're interested in minus the average divided by the standard deviation. That score tells us how many standard deviations we are above or below the average. How far do we deviate from the average? Okay. Now let's just say there are 2 students. This first student got an 84 on this test, and the second student got a 71 on a different test. Now, the person who got the 71 says, but our test was definitely harder. In fact, the teacher told us that our test was harder. So I wonder who actually did better in comparison. So what you might do is take a look at the average and the standard deviation. Okay, let's do that. Okay, so here's the average and the standard deviation of the 2 tests. All the people that took the test. The average was an 80, which this student did better than the average. And then the other test, it looks like it was harder, because the average was 65, and this student did better than the average too. But what are their percentiles? Okay, that might tell us a better idea of where they compared to the rest of the group that took the test. Now, let's do the z-score for both of these, and I'll just write it out. So, this shows us that the student that got the 71 actually had deviated above the average by 1.2 standard deviations. So she's higher on that graph than 1 standard deviation. So in comparison, it looks like the person who got the 71 on this tougher test actually did better than the person that got the 84. Now, how much better? That's when we do normal CDF. Okay, so remember, we do second vars normal CDF, and the calculator var stands for variables. Anyway, now in your calculators at home, you don't have that nice place to put all those numbers. So all you do is just put negative. For this one, you would just put in negative 1,000, comma 1. That's it in this normal CDF, and it should come out with 0.84. And then, of course, this other one, same thing. You put in negative 1,000 and comma 1.2, and we'll see what that says. Okay, so I'm kind of jumping ahead into section 2.2, but anyway, that's how we use this stuff. So basically, this person who got the, oh, that's kind of weird. I didn't do that on purpose, but the 84 actually got him the 84th percentile. That's not usually the case. Anyway, and the 71 actually got the 88th percentile. Okay, so there we go.